this x equals both belongs to given interval r. Okay, so if you assume that, if we assume that if this y1 and y2, there are two linearly independent solution of this homogeneous linear differential equation, this means that equals to 0. So if y1, y2 are the solutions of this homogeneous differential equation, and if we let, say, simple y be, this y denotes a solution of given this non-homogeneous differential equation. So this is the solution of, say, y be the solution of this homogeneous non-homogeneous differential equation. Okay, so this means this y1, y2 are the solution of this homogeneous differential equation. This that equals to 0. Okay, and y be the solution of that. So we are interested to find what is the value of y. If we have a y1, y2, or these are given, or we can find this solution from the homogeneous differential equation, then how can we find that is the general solution of this non-homogeneous differential equation? Okay, so here if y1, y2 are the solution of this homogeneous differential equation, this means these two are twice differentiable function. Okay, similarly, if this y be the solution of this second order linear differential equation, then this solution is twice differentiable function. Okay, and we know that in previous class, if we know that if un or we can say u and v are twice differentiable function, then we know that this u of lv minus v of lu, this equals to a naught x d over dx of Roskian uv plus a1x Roskian of uv. Okay, so this thing already we have tried in last class. Okay, so here if you replace this one, so here we will do only one part, and second part is the similar part. So you can you will derive that part, similar to that part accordingly. Okay, so here if we replace here, we replace this u and v, this u and v in this equation. Suppose this equation is, say, star. Okay, so if you replace this u and v by this y1 and here y, because these two are twice differentiable function, so we get this relation is d over a naught x d over dx of Roskian of this y1 y plus y1 y plus, okay, so a naught this thing plus a1 x Roskian of y1 y, that equals to here we put u equals to y1, so here u equals to y1, so this is y1 l y minus V means second one. We got here y. So this is y L of y1. Okay. So if you replace u and v in this formula, so you get this relation. Okay. And here this term, since y1 and y2 are solution of this homogeneous, so this means y L of y1 is 0 and L of y2 is 0. The L of y1 is 0. And what is the value of Ly? So Ly is the solution of that equals to dx. So this equals to dx. Okay, so this implies this relation can be reduced into, we can write here what is y1 and dx. And if we divide by this a naught x to both sides, so we get d over dx of Roskian, and that is y1 y plus a1x over a naught x Roskian of y1 y, this thing, and this equals to, in right hand side, this y1 dx over a naught x. So this becomes y1 dx over a naught x. Okay, so this form reduced into this form, and look here. This is the this is something any function. Okay, so d by dx of that part plus something of that. This is the first order linear differential equation for this Roskian of y1 y. Okay, so what is the solution of that type of linear differential equation? So if you have dy by dx plus py equals to q, then the solution of that is you know that integrating factor is e to the power integral 2 dx, and the solution of that is y into integrating factor, that equals to integral of q and integrating factor dx. Okay, so here we can try to solve this problem. In next page we rewrite this
सर
हाँ
सर
हाँ बोले
सर ये लास्ट टर्म जो है y1
हम्म,
y1 dx अपॉन a नॉट x होना चाहिए ना
हाँ तो ए नॉट एक्स ही तो लिखा है
सर
वाई वन डी
a1
ए नॉट दिस ए नॉट ओके ओके दिस जीरो जीरो थोड़ा सा छोटा बन गया दिस इज ए नॉट ओके दिस ए नॉट बिकॉज हियर ए नॉट ओके दिस ए नॉट टर्म से हमने डिवाइड किया दिस इज ए नॉट ओके जीरो छोटा से इसलिए वो वन दिख रहा है ओके सो नेक्स्ट पेज okay, so we can rewrite this form. This is d by dx Roskian of y1 y plus this is a1 x over a naught x, okay, a naught x, and the Roskian of y1 y, that equals to y1 dx over a naught x. Okay, this is a naught x, a naught. Okay, so here you can know that this is a which is our differential equation for this y1 y. So hence you know that for we using initial condition, then we can write directly, or you can write this Roskian of y1 y. Integrating factor is exponential e to the power, means exponential of this integral, that is p dx. This is your p, so a1x on a naught x dx. Okay, and that equals to integral that is q is this part, so you can write here this is the exponential of integrating factor, that is same one, so e1 x over a naught x dx. Okay, and okay, so if you're using the initial condition, then okay, so we can write directly as okay. So I think we can write this directly as by using initial condition. So, okay, so we can write this term as if you putting the initial condition x naught to x, then this is the say another variable. Say this is z a naught z dz. This equals to exponential of that x naught to x, exponential of say this is from any other variable. Okay, say this is say function of u a naught u du, and this is y1. This part is y1z and dz over, so whole divided by this by a naught z, and this integrate with respect to dz. Okay, so uh, we can rewrite this is the this exponential of your pdx, and here we use here initial condition, so that's why here we change this variable z. Okay, so this integral in terms of z, then if you put in the upper limit and lower limit, so this becomes the function of x only. Okay, similarly look here, this is the u. Okay, because this integral is simply this integral if integrate with respect to z finally, and then we putting z equals to x. So finally, this is the function of x. Okay, so each term is function of z. So this is z, this is z, and this is a function of z. So that's why we relate this is integral z0 to z, and this is we change the variable say u. This is function of u. Then we put in the upper limit and lower. This is function of z. So whole this is function of z. Then we integrate. This is function of z. Then putting here upper limit and lower limit. This will become the function of x. Okay, so that's why we change here. This is the variable. Okay, so this implies this Roskian of y1 and y. This can be rewritten as if we take this exponential term in the right hand side, this becomes minus sign because this is exponential of that is equal minus of that sign. This is equals to x naught to x a1 z over a naught z and dz, and the product of the second term is this thing, and this is exponential of z0 to z a1 u over a naught u du, this into y1 z d function of z and upon a naught z and whole integral integrate with respect to dz. Okay, so this is your say this is question number, if we write this is the star. Okay, and here if you look here this term. Okay, so if we okay, so now so we have used the initial condition. Okay, so if you use the initial condition, so now okay, so here we can write directly we use Abel's formula, because you know that formula. So if we use Abel's formula, so we get what is your Abel's formula? So Abel's formula is here we can rewrite what is the Abel's formula for that case. So y1, if we take y1 and y for that equals to k exponential of minus integral of x naught to x a1 x upon a naught x and dx. Okay, so this is a say this is function of u. Okay, so this is function of u. Then you find This is function of x. Okay. So or you can replace this u by z or any variable. Okay. So by using Abel's formula, so this is your Abel's formula. So look here. This term is exponential of minus x naught to x is it this term, but here missing term is k. So if we multiply by k here and divide by k, because k is a constant, so if we k and k here, okay. So if we multiply here k and divide by k, okay. So this part becomes the Roskian of y1 y. Okay. So now this equation two can be reduced into what is the Roskian of that. So here what is the Roskian of that. So if you are able to find what is y1 y, the Roskian of that is equals to, this is y1 at x0 and y, or we can write directly it's Roskian. So y1 y, y1 prime y, so y prime. So this equals to y1 y prime minus y y1 prime. So here what is the value of that Roskian? So this equals to y1 y prime minus y y1 prime. That equals to this term k of that is equals to Roskian of this term. We can write Roskian of y1 and okay, sorry, this this becomes a y1 and y2 because Roskian of that two, you know that Roskian of uv is equals to k exponential of this is your level formula. Okay, so we write this a1x over a naught x, okay, dx, where this uv satisfies your relation. Here the one condition is mentioned that in last class you had seen that here you can write lu and lv, this equals to 0 lv. Okay. So that's why here y1 and y2 are the solution of that. Then this condition is holds. Okay. This is your L's formula. This is your L's formula. So here y1 and y2. In fact, y1 we in starting in this derivation we take y1 and y2 be the two linearly independent solution of this homogeneous one. Okay. So here we can write this y1 and y2. Okay. So okay. So this is this condition y1 and y2. The Roskian of y1 y2 that equals to this thing. Okay. So using that formula y1 and this, so here we can write this is the y1 and y2. This value is y1 and y2, and what is the value of this y1 Roskian of that? This equals to this thing. Okay. So this equals to this thing, and this value is equals to Roskian of y1 y2 because y1 and y2 are two linearly independent solution of this homogeneous one. And if this homogeneous solution, then Roskian of that too is defined by this formula. Okay. So this integral x naught to x, and look here, if we this term is we try to write this term in denominator, so this becomes k times exponential of minus sign. Okay, so k times exponential of minus sign, this becomes also this term. So here the numerator term is y1z dz, and denominator you can write a naught z into k exponential of this term is, if you write in denominator, this is a1u over a naught u du. Okay, and that integral with respect to dz, we have to integrate that. So here we can rewrite this Roskian of y1 y2 integral x naught to x y1z dz, this upon this A naught Z, and this term, this K times this is the formula of that Roskian. This is a Roskian of Y1, Y2. Okay, this is dz. So you can find this y1 y prime minus y1 prime, that equals to this thing. So suppose this is your formula, and if we uh, write this formula by say triple star. Okay, so now in similar case, if we derive same thing by same thing by using y2 and y. Okay, so if we take another solution y2 in same manner, you can find the same relation by y2 prime, y2 y prime minus y of y2 prime, that equals to Gaussian of that in this term. Okay, so if we recalculate this same formula by using, if we replace y1 by y2, so you get, you can write directly in next page you can write.
सर
हाँ हाँ, बताएं.
सर एक बार वहाँ सेकंड लाइन में वो लिमिट कैसे हुआ है वो
Second
बता
line,
दीजिए।
here we use initial condition because in that sense, if we use initial condition, then we here don't try to integrating constant c. Okay, so in general, if any ordinary differential equation of first order, you dy by dx plus py equals to q, then the solution of that linear differential equation is y into integrating factor, that equals to integral integrating factor q. Okay, that thing. Okay, here we write here. This is here that in your problem they are given us some initial condition. Okay, this means x is something from x naught. There are some initial conditions are given. So that's why we take here limit x naught to general x. So if we take that limit, so in here in integrand, here we change that variable, because if you write this is a function of x, then dx, then you integrate this is function of x, then integrate, and then upper limit is same. Okay, so that's why we change here say enter variable. So if you integrate this with respect to z, this is a function of z, then you putting here, so this is from that upper limit and lower limit. So that's you get this is function of x only. Okay, because x not be the constant one, and this is your initial condition are given. So इसमें हमने कुछ भी ऐसा नया नहीं किया है, सिंपल ये किया है कि हमारा जो सोल्यूशन होता है, सोल्यूशन में हमने जो इनिशियल कंडीशन है उसको हमने मेंशन कर दिया, मेंशन कर दी, और यहाँ इंटीग्रेंट को हमने इसकी वेरिएबल को हमने चेंज कर दिया, बिकॉज कि ये आपका एक फंक्शन होगा, वहां पे हम एक जो भी हम इसकी अपर लिमिट और लोअर लिमिट आप पुट करोगे, तो दिस इज अ सिंपल फंक्शन ऑफ एक्स. ओके, तो सेम फॉर्मूला है इसमें, कोई यहाँ पर आप देखें तो यहाँ पर हमने यू इसलिए कर लिया क्योंकि बिकॉज दिस इंटीग्रेंट इज अ फंक्शन ऑफ जेड ओनली, बिकॉज हम जेड के साथ हम इसे क्या कर रहे हैं, इंटीग्रेट कर रहे हैं. तो इसको z हमें करना है, ये z का फंक्शन है, ये भी हमारा z का फंक्शन होना चाहिए. इसके लिए हमने क्या किया कि यहाँ पे हमें जो इनिशियल कंडीशन है दैट इज इन द फॉर्म ऑफ z लिख दिए. ओके, सो ये आप किसी वेरिएबल में इसको आपने सॉल्व कर ली. ओके, तो सॉल्व करना हमें x, आप x भी लिख सकते हो, लेकिन x लिखने में फिर कंफ्यूजन होगी, इसलिए हमने x यहाँ नहीं लिखा, क्योंकि जो भी आप लिखोगे वो आप अपर लिमिट पुट करोगे तो दैट इज फंक्शन ऑफ z. दिस इज फंक्शन ऑफ z, एंड देन यू इंटीग्रेट all this integrand, and then putting here x equals to z equals to something this minus this is your constant one, because this is given. That's why here we not adding here integrating constant something c. Okay, in a particular case that if there are no initial conditions are given, that in that sense you have to add here integrating constant c. Okay, so
ओके
is
सर।
it clear to you?
यस सर गॉट इट।
ओके, एंड देन सिंपल स्टेप्स हैं उसको आप कर सकते हो. Okay, so in next page, if we rewrite this formula and calculate for y2 and y, then the other formula, or we can write have a equation which is defined by triple star. This as well could have been derived been derived with y2 in place of y1. So our formula is this: we replace that y1 by y2. So you can solve this, and y2 z dz over this dz. Okay, and say this is your next equation, that is this thing. Okay, so from above two equation, from equations 3 star and this 4 star, you can find and easily obtain. Okay, so what is first formula is yeah, y1 y prime that minus y of y prime. Okay, this thing. Okay, so if look here, if we using these two formula, and if we multiply by this equation number third by if we here, because right hand side you have y1 y2, this is y1z and dz over a naught z Gaussian of y1 y2 and dz. Here this is y1 and here this is y2. So if we multiply this equation by y2, okay, and in this equation we multiply by y1 and try to adding subtract these two, so this part is 0. Okay, so no. So if we multiply by y2 and this part is y1, so here we are interested to find the value of y here ना. So basically y term is this thing. Okay, तो y term के लिए हमें क्या करना होगा, y term में चाहिए तो this y1 prime और y2 prime, this term को हमें eliminate करना है. Okay, so this term को हमें eliminate करना है. We are interested to find general solution, that is y. Okay, so if we multiply by y2, so this becomes y2 y prime. Okay, and here y1 y prime. And now if we subtract these two, so this term is eliminated. Okay, so this means you can write here from y2 into this 3 star equation minus y1 of this x multiply कर रहे हैं आप किसमें, 4 star में. Okay, so you can find if we multiply and then subtract, you can get here this is y. Okay, so this y into y1 y2 prime, this first one minus of this, so this term is cancelled and this minus, so this if we multiply by here, so this term is minus, and if we minus of this term is plus. Okay, so our okay, or we can multiply here because we are interested to y1 y2 prime. So if this minus this करें तो जाते हैं, so if this y2, so this becomes minus y1 prime y2. So this if we multiply by y2, okay, y2 in third equation, minus this equals to Gaussian of y1 y2, because these two are same, and here we multiply by y2. Okay, so this thing you can write y1 with y2, y2 and dz minus here you multiply by y1. This is y1 and y2. So okay, so if you multiply by y2x here, okay, okay. So you can write this y2 minus dz. And here, if we take y common, so this becomes y1, y2 prime, y2 prime minus y1 prime, y2. That equals to, if we take y1, y2 are common and try to rearrange this term, this becomes x naught to x, so y2 x, y1 z dz, and dz is most common, so this minus y1x y2z, so you can write in same manner like y2z y1x, and this multiplied by this dz is common. Denominator term is a naught z Gaussian of y1 y2 whole integrate this is dz. Okay, and what is the Roskian of y1 y2? This is the determinant y1 y2 y1 prime y2 prime. So this equals to same y1 y2 prime. That this is the Roskian of y1 y2, and this is the Roskian of y1 y2. So that's why these are cancelled out. So we uh, find this general solution, that is yx. This equals to, this is y equals to integral x naught to x, and this is y2x minus y1z, uh, y2x into y1z minus y2z into y1x. Denominator term is, this term is a naught x Roskian y1 y2, and this is dz. Okay, so this is your final formula. What is the general solution? That general solution is yx for non-homogeneous differential equation is, general solution is this thing y2x y1z. Okay, so here this is you integrate this with respect to z only, and then multiply by y2, because here this term is outside that integral. So
तो लास्ट में ए नॉट जेड होना चाहिए ना लास्ट
yes,
तो
this is
नीचे
A naught Z. Yes, 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 this is A naught Z. Okay, so here, here we can rewrite that formula. Rewrite this formula. So what is the general solution? The general solution is yx is equals to integral x naught to x y2 x y1 z minus y2 z y1 x, and that multiplied by this term dz, t of z, and then integrate dz. Okay, so this multiplied by your non-homogeneous term, this is dz, t of function of z, denominator term, this is integrate, this is a naught z, and Roskian of y1 y2, Okay, this and this whole integral integrate with respect to dz. This is your non-homogeneous function dx, that part, and this is integrate with respect to dz, and then putting your integral. If this is initial value problem and this is initial value problem, then this whatever the conditions are given here, so you putting that one. And if this is non-initial value problem, in that sense, you simply integrate this term plus adding, okay, some constant here. Okay, so this is the final solution of non-homogeneous linear differential equation. Okay, in that case, if y1 and y2 are two homogeneous, two linearly independent homogeneous solution of that Ly equals to 0, then in that case you can find the Roskian on that too and all those terms, and then you can find directly what is the general solution. Okay, so this is the formula, and you can find direct solution from that formula. Okay, so the next one is what is the matrix exponential? Okay, so in next page, okay, so if you have to solve some dy over dx that equals to a of y with n cross n constant coefficient matrix, and this matrix is constant, so this is a matrix A. Okay, and here the unknown vector function, if we take yx, and that is the column vector whose components are y1, y2 up to yn x. This is the column vector. Okay, so then you know that the general solution, the general formula in matrix exponential form what is the yx, this equals to e to the power this thing into constant. Okay, let's see. Okay, so you know that this is a dy by this y equals to a of dx, then integrating to both sides, that equals to log y, so that's y equals to exponential of this xa plus log c, and that c is a constant vector. Okay, or you can rewrite this is e to the power xa, and this is c1, c2, 2. There are cn. This is column vector. Okay, and here you know that it's all c1, c2 up to cn are arbitrary constant. Okay, these are the constants. So what is the solution for initial value problem? So the solution of the initial value problem by this simple problem, this is dy over dx, that equals to ay, and here the initial condition are given. This is a y of at x naught, this equals to y naught vector. So and that same the general solution is given by, this is given by the yx. Okay, so this is capital yx, this is the general solution, that equals to e to the power, if you're using initial condition, so x minus x naught, this means here we put here if y equals to y0, that equals to 0, this means 1, that equals to c, then we can find what is the value of c is x to the power x naught here, and then here putting here, that equals to e to the power this thing, because c equals to e to the power minus x naught a, and then here putting e to the power x naught a, then we adding product of that 2, so x minus x naught, and that a, and what is your initial condition is y0. Okay, so this is your general solution for initial value problem. So look here, we are interested to find what is the value of this e to the power x a exponential of x a, where a be the matrix. Okay, a be the a matrix of order n cross n. So first of all, we have to learn how to calculate this exponential to the matrix exponential. Okay, so what is the definition of matrix exponential? So the definition, what is the definition? So definition is matrix exponential. So for a square matrix, say A power e to the power xa, this equals to by using the formula, exponential formula, you know that this is equals to summation k equals to 0 to infinity x to the power k over k factorial, this e to the power k. Okay, so this is your exponential formula. Okay, so this to the power k over factorial k, and in matrix form this equals to I identity matrix plus x of this A matrix plus x square over factorial 2 A square, x cube factorial 3 A cube, and so on. Okay, so this is the formula of matrix exponential. So here, if there is a matrix of square matrix of simple type matrix, this means if you have to calculate a, then a into a square, a cube, and if the a square, a cube are in the power 4, if equals to 0, then you are able to find use this formula. ओके, ऐसे ऐसी मैट्रिक्स में आप ये फॉर्मूला यूज कर सकते हो जहां एक्सपोनेंशियल निकालना हो, ऐसी स्क्वायर मैट्रिक्स जहां पे उसके हायर ऑर्डर मींस a2 a3 a4 मींस उसके जो है अगर आप जीरो आ जाती है तो उसके बाद फिर आपके सारे टर्म्स जीरो हो जाएंगे, तो उस सेंस में आपको एक्सपोनेंशियल निकालना आसान हो। ऐसी मैट्रिक्स जिसमें कि आपके स्क्वायर ए क्यू ए फोर वो नल मैट्रिक्स ना हो, तो उस सेंस में आप एक्सपोनेंशियल नहीं निकाल पाओगे बिकॉज दिस टेंड्स टू इंफिनिटी। तो उसके लिए हमें क्या करना होगा, उसके लिए हमारे पास अनदर अप्रोच है। तो ये सिंपल फॉर्मूला हम वहां यूज करेंगे जहां हमारी मैट्रिक्स ऐसी हो जहां पे हमारे 2 या 3 ऑर्डर के बाद जो है वो जीरो हो जाती हो, ताकि कैलकुलेशन हमारे आसान हो और हम इसको इजीली हम फाइंड करें। सपोज ए टू द पावर 15 अगर जा करके जीरो हो रहा हो, तो ऐसी मैट्रिक्स में ये फॉर्मूला लगाना आप बहुत ही मुश्किल है। आप उसको यूज करोगे एक की पावर 15 तक जाओगे, फिर उसे कैलकुलेट करोगे, फिर सारे टर्म को ऐड करना, तो उसमें प्रॉब्लम होगी। तो ये फॉर्मूला हम सिर्फ वहीं अप्लाई करेंगे जहां पे हमारे अप टू सेकेंड और थर्ड ऑर्डर पे जाकर के वो जीरो हो जाए, ताकि हमारा कैलकुलेशन में ज्यादा टाइम भी ना लगे और हम इजिली एक्सपोनेंशियल हम फाइंड कर पाए। ओके, सो अगर आप एक एग्जांपल अगर हम यहाँ दें, अगर हम एक मैट्रिक्स लिखें A, if this is a matrix A and that matrix is suppose okay, so first row is 0 0 0, second row is
हेलो सर।
हाँ
अच्छा, मैट्रिक्स को देख के कैसे पता चलेगा कि ये फॉर्मूला लगाना है या किसी और, मतलब हम तो पहले
बिल्कुल जो इस तरह की आपकी मैट्रिक्स हो ना, जिसमें आपकी ट्रायंगुलर मैट्रिक्स टाइप की हो, ज्यादातर एंट्रीज आपकी जीरो हो, ओके, तो उस मैट्रिक्स में आप देख करके आप जैसे ये छोटी सी मैट्रिक्स में लिखा ना, इसमें देखिए सारे 0 0 0 है, तो इसकी पॉसिबिलिटी है कि आप सेकंड थर्ड ऑर्डर में आकर जीरो हो जाए। ओके, सो दिस इज जनरल फार्मूला, ओके। और अगर आपकी मैट्रिक्स सपोज आइडेंटिटी मैट्रिक्स टाइप की है, तो फिर आप क्या करोगे, उस केस में फिर आपके कभी भी वो आपके किसी भी ऑर्डर में जाएंगे तो नहीं हो पाएंगे। तो आप ऐसी छोटी मैट्रिक्स अगर आपको दिखती हो जहाँ पे कि आपको देख के लगे कि हम इसकी ए स्क्वायर ए क्यूब में हमारा जीरो जाने के चांसेस हैं, कैलकुलेट कर लिया, देन आप इस फॉर्मूले पे जाओ। और अदरवाइज एक जनरल फॉर्मूला है, उस पे हम बाद में आएंगे, उससे आप डायरेक्ट उसी से करो, हर हर प्रॉब्लम उसी से करो, बट ये भी एक मेथड है, तो इसलिए हम इसके बाद हम उस पे जनरल मेथड पे जा रहे हैं। ओके, कि कैसे एक्सपोनेंशियल मैट्रिक्स हम कैलकुलेट करेंगे। तो फर्स्ट वन इज ये, चूंकि हम आपके एलिमेंट्री फॉर्मूले से हम लेके आ रहे हैं, एक्सपोनेंशियल मैट्रिक्स हम कैसे निकालेंगे, आपका यूजुअल जो एक्सपोनेंशियल फंक्शन है उसके थ्रू। ओके, देन हम एक फॉर्मूला देंगे आपको जिससे आप जनरल निकाल सकते हो, इस मेथड की जरूरत नहीं होगी। तो आप हर एक प्रॉब्लम में आप उसी मेथड से निकालो। ओके, ठीक है। और अगर आपको लगता है कि नहीं हमें इस फॉर्मूले से भी अगर हमारा सेट हो जाता है, अगर इस तरह की प्रॉब्लम है जैसे हमने ये लिया, और तो यहाँ से भी आप चेक कर सकते हो, दोनों मेथड है, वो आपके ऊपर है। ठीक, ओके। तो एक्सपोनेंशियल मैट्रिक्स में ए, इफ वी टेक दिस मैट्रिक्स ए, देन व्हाट इज ए स्क्वायर? ए स्क्वायर मींस 0 0 0 1 0 0 0 1 0 multiplied by same 0 0 0 1 0 0 0 1 0, and this equals to, this first one is 0. What is a square is, this is 0, this is 0, this is 0 because this first one. Second से अगर आप multiply करें, this is this into this 0 0 0, last one this 0, this is 1, here this is 1, and this 0 and 0. This is your a square. Okay, what about a cube? So a cube, if you multiply this with a, so here this first one is 0, okay, second one is 0, third one is 0, and here this second to this term is 0 0 0, and here this becomes 0. A cube is 0. This is null matrix. Okay. Here this a cube term is 0, so here what is that? This multiplied by a square, and that is,
सर आपकी आवाज सही जा रही है, साफ साफ नहीं है।
क्या आवाज क्लियर नहीं है? हेलो,
यस तो क्लियर है।
बीच में ब्रेक हो गया।
क्लियर है? ओके 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 ओके। तो आप देख लें, दिस इज एक्स स्क्वायर बाय 2, एंड व्हाट इज द वैल्यू ऑफ ए स्क्वायर? ए स्क्वायर इज 0 0 0 1 0 0 and 0 1, what is this is 0 0 0 and this 0 0 0 1 0 0. Okay, so okay, so here a cube is 0, so that's why all exponential matrix that becomes 0. Okay, so here what is the exponential of that matrix A? This equals to finally, this is first term is 1. If you're adding this term, this is 1 0 0. Second term is x, here multiplied by this x. Okay, x 1 0. Last term is x square by 2. Then here multiplied by x, and this is 0. This is exponential matrix. So finally, हम इसे फिर से लिखते हैं कि what is exponential matrix? So e to the power xa is the matrix. This is 1 x square by 2. This is 0 1 x. This is 0 0 0. This is the final solution of this e to the power xa.
0 0 1,
So 0 0, अच्छा यहाँ 1 है। ओके 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 ओके, ये 1 1 1 1 1। 0 0 1. ओके, ये दिस इज 1 1 दिस 1, ठीक। तो आइडेंटिटी मैट्रिक्स है, तो आप इस तरह से इसको सॉल्व कर लोगे तो ये आपकी क्या होगी, आपकी एक्सपोनेंशियल ऑफ x से आपने निकाल लिया। ओके, तो इफ एनी मैट्रिक्स A is given then you can find easily what is your exponential of e to the power x. Okay, so in next case, if our matrix is of diagonal type की मैट्रिक्स अगर हम इसको बना लें, अगर हमारी ये मैट्रिक्स, क्योंकि हमारे पास दो चीजें हैं कि हमारे पास एक ऐसी मैट्रिक्स हो जो कि हमारी हायर ऑर्डर में वो जीरो हो जाती हो, तब तो हम ये फॉर्मूला यूज कर लेंगे। अदरवाइज क्या है, दूसरा फॉर्म है कि उस मैट्रिक्स को हम क्या करें, डायगोनल फॉर्म में हम रिड्यूस कर लें। डायगोनल फॉर्म में कर लेंगे तो हमारी जो डायगोनल मैट्रिक्स आएगी तो उसकी जो हमें पावर्स हमें जो लिखनी होगी उसके लिए हमारे पास एक अलग फॉर्मूला है। सॉरी, तो एक फॉर्मूला और हमारे पास है कि हम कैसे हम मैट्रिक्स को डायगोनल फॉर्म में डायगोनाइज कर लें और उसके बाद फिर हम एक्सपोनेंशियल मैट्रिक्स उसकी हम निकालें। तो दो फॉर्मूले हैं फॉर एनी सच टाइप ऑफ मैट्रिक्स, लेकिन जनरल फॉर्मूला क्या होगा वो हम नेक्स्ट टर्म पे हम बताएंगे, हाउ टू कैलकुलेट द एक्सपोनेंशियल ऑफ दैट मैट्रिक्स और बाय यूजिंग फंडामेंटल मैट्रिक्स। ओके, तो वहां पे एक्सपोनेंशियल मैट्रिक्स निकालने के लिए हमारे पास एक कॉन्सेप्ट है फंडामेंटल मैट्रिक्स की। तो क्या फंडामेंटल मैट्रिक्स होती हैं, कैसे हम फंडामेंटल मैट्रिक्स को यूज करके एक्सपोनेंशियल मैट्रिक्स हम निकालेंगे। ओके, तो आज टाइम हो गए हैं आपके, तो आज हम ये दोनों पोर्शन जो है सोचा था कि आज ही कराएंगे, बट ओके कोई बात नहीं। तो हमसे कल जो है हम एक्सपोनेंशियल मैट्रिक्स और एनी मैट्रिक्स व्हिच कैन बी डायगोनलाइज्ड, ओके, और उस मैट्रिक्स की एक्सपोनेंशियल मैट्रिक्स हम कैसे निकलेंगे। दूसरा कि हम हाउ टू यूज द फंडामेंटल मैट्रिक्स एंड इवैल्यूएट द मैट्रिक्स एक्सपोनेंशियल, एंड एक आध दो पे न्यूमेरिकल भी कर लेंगे। ठीक है, तो कल के लिए हम ये चीज करेंगे कि फंडामेंटल मैट्रिक्स और कुछ 2-3 न्यूमेरिकल उस पे हम कर। ओके, ठीक है, तो आज के लिए इतना ही। आप नेक्स्ट क्लास कल हम 10 बजे बाकी पोर्शन करेंगे, क्योंकि अभी स्टार्ट करेंगे तो इतने टाइम नहीं है, ऑलरेडी 10:59 हो चुके हैं, तो आपकी क्लास। ओके, थैंक
यू सर।
यू।
थैंक यू सर।
थैंक यू सर।
थैंक यू।
थैंक यू सर।
थैंक यू सर।
Thank you to all of you.